Hi, we're here to explain some exponents problems with negative exponents for you. Remember the rule. It's written at the top of page 20. Negative exponents will turn positive when moved to the opposite side of the fraction bar. Why? Because of dividing by a fraction. Remember, negative exponents make positive fractions. So we end up dividing by fractions, multiplying and dividing by fractions. All of that leads me to what rule? Negative exponents turn positive when moved to the other side of the fraction bar. So let's look at problem I on page 20. Negative 5 is the coefficient. It has an exponent of 1. Not negative 1. The negative 1 only applies to the E. The negative 6 applies to the F, and the G has an exponent of 1. So let's create a fraction bar. Everything right now is on the top. The only things that will stay on the top are those bases with a positive exponent. So negative 5 and G is being multiplied on the top. Then those bases with negative exponents move to the bottom and the exponent becomes positive. So we have negative 5G over e to the first f to the 6.
All right, we're gonna look at another problem. So we're still on page 20. We're gonna go to problem B.
So here we're gonna use the product of powers property first to multiply a to the negative 5th times a to the negative 2. Again, no parentheses, so this negative 5 exponent only applies to the a, and this negative 2 exponent only applies to the a. So keep the base, add the exponents, and we get a to the negative 5 plus negative 2 is negative 7. Then we have 4 times 2 left. They're not the same base, so we can't keep the base, add the exponents, but we can multiply 4 times 2. 4 times 2 is 8. We cannot leave an answer with a negative exponent. Therefore, we have to simplify this. Negative exponents turn positive when moved to the other side of the fraction bar. But the only thing with a negative exponent is the a, because the 8 has an exponent of positive 1. So we'll draw our fraction bar. 8 stays on top, and a to the 7th, it turned positive because we moved it to the other side of the fraction bar. Now we're in simplest form.
All right, we're also gonna do C right below it from page 20.
Okay, so C, first I have these parentheses. I'm gonna look at these parentheses and notice there's no exponent outside the parentheses. There's no exponent outside the parentheses. So all this is multiplication. We are multiplying each one of these terms, and we want to multiply the ones that have the same base. Same base, product of powers, keep the base, add the exponents. 2. There's no other base of 2, but there is another just numeric value that I can say 2 times negative 3. 2 times negative 3 is negative 6. So I've used the 2 and the negative 3. X to the 3rd power times x to the negative 5th power. Keep the base, add the exponents, and I get x to the negative 2 power. Y to the 8th power times y to the negative 2 is y to the 8 plus negative 2 is 6. Z to the 4th times z to the negative 6 is z to the 4 plus negative 6, which is negative 2. So the first thing I did was the product of powers property, keep the base, add the exponents. Now I'm going to simplify it so that my answer doesn't have any negative exponents. Draw a fraction line. Negative exponents turn positive when moved to the other side of the fraction bar. So what has a negative exponent? The x does. So let's move it to the bottom and turn the exponent positive. The z does. So let's move it to the bottom and make the exponent positive. What doesn't have a negative exponent and therefore does not move? The negative 6 is just a negative number, not a negative exponent, a negative number. It stays right there on top where it was at. The y to the 6th stays on top because the exponent is positive. And ta-da, there's our answer for C.
Awesome. We're also going to do on page 20, letter F. So, down at the very bottom, we're at F.
This one is a little different because unlike the last one, this one does have a number outside of the parentheses. Because there are multiple bases inside the parentheses, this -2 is applied to every base. So you can either draw an arrow. It goes to the number, it goes to the A, and it goes to the B. We're going to use the power to a power property where we keep the base and multiply the exponent when we have an exponent raised to another exponent. For example, that's going to be B to the -5 times -2, and a negative times a negative is a positive 10. And then that's going to be A to the 4 times -2, and a positive times a negative is a -8. And then -3. Well, what's the exponent here? Anything that is just a regular number has an exponent of 1, we don't have to write it. The only reason I say that is because you're also multiplying exponents 1 times -2, so the -3 has an exponent of -2. Notice, I left -3 in parentheses because it's a negative base, and this exponent applies to both the negative and the 3, so we want to leave that grouped in parentheses. Now, let's make it so that our answer doesn't have any negative exponents. Negative exponents turn positive when moved to the opposite side of the fraction bar. Everything's on the top right now, so let's draw a fraction bar. Which one has a positive exponent and stays on the top? B. So it's B to the 10th. Then -3 to the -2 has a negative exponent, so I'm going to make that -3 to the +2 in the denominator. A to the -8 becomes A to the +8 in the denominator. One more step because we've got a perfect square. What does -3 squared mean? It means -3 times -3, and -3 times -3 is +9. So we have 9A to the 8th in the denominator and B to the 10th in the numerator.
All right, Miss Mullinax, we're almost at 8 minutes. Do we want to stop and do a brain break and then make another one?
Yeah, let's stop.
Okay, we're going to stop.